calculator. All right, so where's the colors? There we are. So if we have 3.65 times 10 to the 24th atoms, what goes on the bottom? What's on top?
Atoms.
What goes on the bottom? Whatever's on top has to go to the bottom, so it'll do what? Cancel out. All right, so if atoms is on the bottom, what are we going to put on the top?
1 mole.
We're going to put moles on the top. We'll come back and do the numbers. Okay? So, do I want moles or do I need to keep going?
You want mole.
I want moles, so I only need a two-step chart. So, on Friday, we learned we had 2 conversion factors. All right, and which one am I going to need? The one that says moles and atoms or the one that says moles and grams? So, given that, moles is going to get a what?
1.
A 1. And atoms is going to get what?
The special number.
The special number. Do we know its name instead of referring to it as?
A.
It starts with an A. Anybody remember how to pronounce it? Avogadro's. Avogadro's number. Okay? So, when we punch that in, what'd y'all get? 6.06. I need 3 significant digits. So 6.06. I wouldn't even round up because there's a 1 after. So is that what y'all got? Anybody else? Yes? No? Got some nodding heads, no voices, but serious. All right, so for number 2, 15.42 moles. We've got grams. We're going to moles. So grams, moles. What goes beside moles?
1.
What goes beside grams?
The atomic mass.
We look up the atomic mass for nickel. Nickel on the periodic table has what atomic mass? 58.69. This is another small voice out there. So 15.42 divide. My fingers are not working today. 15.42 divide 58.69. I got, and I need 4 significant digits this time, 0.2627 and moles, and it does not round up. Questions? You feel okay about those 2? All right, so the last one, we're going to change and find average atomic mass. So how many isotopes do I have?
2.
So I need 2 sets of parentheses.
Oh, you add them?
Yes.
Oh, that.
All right, so my first parentheses would be the mass of 56.98 times the percent abundance, which is 81.5. The second isotope has a mass of 61.58 times the percent abundance, which is 19.5. All right, and the mass of element XY will be 58.44. If you just chop it off 6, but I'm going to round it up and make it a 7. Either AMU or U for the unit. Anybody else get that?
We don't do significant for that.
I told you you can. So if I rounded it off to a 5, would that make you happier? I told you to take it up to the same mass numbers on Friday, so you keep the same digits as the mass.
What am I doing?
I don't know. What'd you do?
Oh, I multiplied it. I did it way wrong, but I got it now. I just was typing like.
So does everybody see how to do it? Are we okay with the 3 questions before we do our homework questions? Yeah. What's wrong, Zyra? Other than you're out there all by yourself because all your friends around you apparently didn't come to school today. It's at the back by the door. Anybody else? Question? All right, let's take a look at your homework. See what kind of questions we have, if any. No, I'm not checking it today. All right, so if we look at your homework questions, 1 through 7B only. All right, number 1, you should have somewhere around 27.0. Now, if you have 26.9, 26.8, they're the same answers. I'll get your sheet in just a second. It won't do you any good to have it right now. What? Number 2, somewhere around 29.5. Again, it does not have to be the exact same answer if it's close. Number 3, 0.5. You need 3 significant digits. So if you have 0.500, 0.499, it's the same answer. Moles. If you have 0.50, you need a 3rd significant digit, so put a 0 at the end of it. Okay?
Wait, so if we put 0.500?
That's correct. That's the first answer I called out.
Okay.
Number 4B will be the same thing, except you need 4 significant digits. So 0.5 and then 3 zeros. Or if you're in the ballpark and you have like 0.4999, okay, any of those answers are fine. You just need to be close to 0.5 with 4 significant digits. Number 5, 4.068 times 10 to the 24th. Now, we might not be exact, so it should be close to that. 6B, I have 6.05 grams. 7B, 1.50 times 10 to the 23rd atoms. All right.
Wait, what?
1.50 times 10 to the 23rd atoms.
And then what, you said something about.
It should be close. So if you have like 1.47 times 10 to the 23rd atoms, that's the same answer. Why did we what?
What was. I'm so dumb. I got my numbers all wrong. I don't know. Wait.
Did you do the wrong question?
No, I don't know.
What number did you start with?
Okay, I got 3 and I got 4. What was the answer to 5?
5 would be 4.068 times 10 to the 24th.
Okay. 6.
6.05.
I guess I didn't do that one. Yes, I did. It's just lost.
Which number did you start with in number 6?
I think I skipped that one, and got out of order of questions. I ended on 7, but I did 7 in the application one, but 6 is lost. Anyways.
7 in the application B. Did you do 7B in application?
I did all the rest of them too. I just
7B in application would be 2.6 times 10 to the 28th.
7B?
I'm only answering for Allie, not the rest of y'all.
What was number 7?
In application problems?
No.
Oh. All right. I thought maybe you said you did 7B out of application.
I did 7B and I ended with those 2, but all the rest of them were out of order. So I was confused.
Gotcha. So the rest of y'all, application problem number 1 should be 39.947. And either U or AMU. All right, questions. Here's I.
Thank you.
All right. So who has a question? Needs me to work something. Anybody? Yep. Number 5 says we have 6.755 moles, and it wants us to find atoms. Okay. Now, the question says, is this one of the ones that's worded weirdly? I don't have the paper in front of me. If you look at question, I think it's 3 and 4. Yeah. In question 3 and 4, see how it says how many moles of atoms? Did they want moles or did they want atoms in number 3 and 4? Where it said moles of atoms. What did they want you to find in 3 and 4 when it said how many moles of atoms? They wanted moles. Okay? So if that bothers you, just scratch out the of atoms in 3 and 4. All right? I will not ask for moles of atoms. I will just simply say moles. All right? But sometimes that throws people off. And number 5, it wants you to find atoms. So what goes on the bottom?
Moles.
What goes on top? All right, what goes beside moles? What goes beside atoms? Avogadro's number. Never changes. Avogadro's number goes beside atoms. What always goes beside grams? Anybody figured it out yet? What always goes beside grams? The atomic mass from the periodic table. What always goes beside moles right now?
1.
A 1. Until we learn to balance, it will always be a 1. In about 2 weeks or less, we'll learn to balance. Right now, y'all don't know how to balance, so every time you write moles, a 1 goes beside it. Once we learn to balance, that will change, but we're not there yet. Okay? So you'll just calculate by multiplying, and then you'll have the answer number 5.
I got exponent of 23.
Exponent of 23?
Yeah.
Okay, so what do I call out?
I think it's 24.
Okay, so 6.755 times 6.022, second EE 23. I did get 24. 4.06, I'm going to round up to 8 because I got a 7 there, times 10 to the 24th. That's what my calculator says.
My calculator says something different, but let me do it again because I probably did something wrong. That's the thing. I hate these. Like, I feel like all the answers that I wrote down are wrong, but they were right. Oh, I wrote down 22 instead of 23.
Oh, that'll do it. What else?
Number 7.
Yep. So number 7 says
It's like the same thing, but like I still got it wrong. So like.
that you have 8.02 grams of sulfur. All right, so if we start in grams, what goes next on the bottom?
Grams.
From a gram, what do you have to go to?
Moles.
Remember, every chart you draw has to have what in it? Has to have moles. Don't skip it, because down the road in a couple weeks when we learn to balance, if you're skipping moles, where are you going to put those coefficients that aren't a 1? Do you have a place to put a 2 or a 7 or a 14?
No.
No, you got to have moles in your chart. All right, what goes on the bottom? What are we trying to get rid of?
Moles.
So put moles on the bottom. And what are we going to? Atoms. That's why on our little notes on Friday, I had this written there. That way, if you had trouble, you could follow. You started in grams, so grams has to go to what? That's why we put moles on top. And for moles, you go to what? So we put moles on the bottom, and then we put atoms on top. Now, if you have grams, what always goes beside grams? What always goes next to moles? What always goes next to atoms? Avogadro's number. It never changes. So when you go to fill in your chart, what goes next to moles? What goes next to atoms? And grams is the atomic mass. So what element do they give us in 7b? 7b has sulfur, S. So we look up there and find S. 32 point.
Oh, I wrote the wrong atomic mass.
That'll do it. Okay. And so to solve, I told you could either divide first and then multiply, or multiply and then divide. You choose. I multiply and then divide, but you do it the way you want. Do you get to keep them?
Mhm.
Yeah, why would I take them back? All right, so I get 1.50. So I need 3 significant digits. I could round it up to a 1 because I got a 5 there. Times 10 to the 23rd and atoms. Anybody? So do we feel like we're ready for the quiz?
Not
Yes?
today. Tomorrow.
Do we need more practice or are we good?
Yes, more practice. Are y'all crazy?
Wait, what would you get for application problem 1?
The answer was
If we
39.94.
to do more practice for a quiz, we should take it.
It's fine. You just rounded up the 7 to a 4. The 7 rounded the 4 up to 5. You got the right answer. Yeah. All right, we'll compromise. We'll only do 3, Precious. How's that? Yeah. All right, so let's see here. Let's do 3C. Let's do 6C and 7C. Those 3. And if we all have those, then we're moving on to naming. Naming compounds. No, the quiz is still on. I won't make you take it today. It's ready. It's photocopied. But we'll do it tomorrow.
Okay, let me put this whole
Okay? Same homework sheet you have in front of you, but those 3. Just for there. Good job. I didn't check homework, so you don't have to video. But you are responsible. We did 1 through 7B only, and we did number 1 for homework over the weekend. Okay? And then we're just doing those 3 to practice. Do you ever check the website to see what you missed when you're out? You might want to start doing that. Okay, instead of going, I can do the whole sheet. No. Yes, you can copy somebody's, you can take pictures of them, you can watch the little bit of the lecture so you can catch up on how to do it. I don't care. But you're required to be caught up. Just throw the trash away. have a question for me? Just look at these dumb questions I'm supposed to respond to now that I've read my 3 pages.
I did that. It's in. I don't know. It's in green. It's not. Oh my god, I get lost on this paper. I did the wrong one. Are you kidding me? That just takes so much time. I don't like this work on this wall.
Huh?
I don't like it. It's all bunched together and it's being nervous. No, it's not.
Anybody got a question for me? You finished? Where we at?
I'm almost done.
Instead of me figuring out if I can post a comment not in my email. We're trying to figure out how to work the system. I have a question, y'all all good? Everybody knows what they're doing, I'm gonna grade a bunch of hundreds tomorrow, right? Deny, yes, no? Got a question for me?
No.
Well, then you should be making 100 tomorrow, right?
No.
Then you gotta have a question.
No.
So you know how to do all 3 questions? You wanna check the answers? See if we got them right?
Yeah.
Okay. Here, come check the answers. if you got them done. Make sure you know what you're doing. How about you back here? No, I can answer the question. Most people are not going to need to go over it. I don't want to go over it. I'd rather just answer your question.
Yes.
That's what they pay me to do. Instead of figuring out how to work the system up there and see if I can sign out and post a comment.
I got them all right.
Excellent. That means I'm going to be grading hundreds tomorrow.
No.
Okay, so the first one you were doing.
Yeah.
Okay.
I don't think
See,
it's right.
which one is it? Number 3. So you had 0.87 grams of nickel. That's right. Put a unit on it.
Oh, really?
Yeah. 76 knots.
Miss Walker, can I stick my eye in the water fountain again?
Yep. All right, so put grams on that.
You got all the answers in here.
Adam.
No.
No.
What numbers do we do?
If grams is on top, it has to go on the bottom. I'm not even asking what number. I'm just asking what unit has to go on the bottom. Grams is on top. What unit has to go on the bottom? Grams is on top. Grams. So erase that little mole stuff. Whatever unit's on top has to go on the bottom so it can cancel out. Okay? Get that one off there. We're not putting any numbers in right now. Yep, no numbers right now. All right, so if you're in grams, what has to go on top from a gram? Don't worry about the numbers. The unit has to go on top of your gram. From a gram is the only thing you can go to. Come on, so put moles on top. Here are the numbers. Here. That is the numbers. You got a little space.
Look at my desk. It just looks stressed
Your number
out.
beside it.
You're a guess.
Now, if they ask you for moles, you're done.
Everywhere.
Well, the question asks you for number 7. 6. Number 6. Yeah. How many what?
What is the math?
I'm doing 6. I don't think I was doing 6.
No.
Yeah,
Yes.
I was doing 7.
Okay.
All right, determine the number of atoms. All right, so we're doing atoms. All right, so you've got moles right here,
Right.
and we want atoms. So erase that, and what do we have to do with the chart? Now make it longer.
I cannot get it.
All right, so what do we put on the bottom? Whatever's on top has to go where? Okay, did you want to go to grams? What the question asked you for?
Adam.
So what are we putting up there?
6.0.
60.
I really don't know what you're telling me. Unit.
Oh.
So what
Whoa.
unit's going up there? What is saying the question? Determine the number of
Adam.
atoms.
Hold on.
Say Adam.
Atoms. It doesn't have an abbreviation. Usually y'all always try to abbreviate it, it doesn't have one. So, is that the number that goes with atoms?
Let me check my
Pay attention.
Yes, so that number's good. What number goes with moles?
Wait, I might be looking at the wrong one.
Number 1's there. Yep, now what number goes with
Where is
grams?
the thing at?
I don't know.
Wait, 7. Wait. What did you do?
Yes, if that's the,
See?
So those right here?
Exactly.
we have 10,
That can't be the same one.
then yes, 39.10 goes there.
That's 6.
And now you're
No,
ready to
so I
solve
can get that
find
for
the
I did not get anything close to that.
Okay. Yes,
Yeah, that's not.
you good?
Miss Wall, where are the right answers?
Look, follow the numbers and the letters.
I did, but this can't be.
This can't be.
Oh, wait, never mind. Oh, I got it right.
Huh?
Ew.
Huh?
Wait.
You refuse to
I
learn
got
it.
to reach it.
So grams goes on the bottom, so we cancel. Moles goes on top. Now, if you want moles, you're done. So we want moles in number 7. So draw another section, draw it longer. Draw it out. So moles has to go where? So it'll cancel. Down at the bottom. And now what you do?
It is
Yeah.
correct. Whoa.
Yes. And then so you multiply these two because they're on top. Multiply those. Divide by that. Okay, if this one wanted moles in 6C, you're done. If they don't want moles here, then we have to make it longer.
Okay,
What did it
never
want
mind.
in 6C? Go ahead and calculate that. Yeah.
What?
We don't have the right unit on the end.
-1.
Oh,
Are these the right unit?
Let me see. 3C would have been moles, 6C would have been grams, and 7C would be atoms.
All right, atoms or AMU?
Atoms. AMU stands for atomic mass units. You'd only write that if you were finding like the average atomic mass.
Oh. I see a paper.
Me too, but we're not getting one.
How would you say we did? Let's just say that. Oh, yeah.
Not here. Maybe another class, but not this one. Okay. You should get a large number because you're finding an atom that has that big exponent. So you should have a large number. That's okay. So write 2.31 times 10 to the 22nd. Now, this one's not finished, which is why you gotta keep picking up. Okay? That's what we're all about.
Okay, around here. Yes, 3C. And 7C, right?
And what do we have in 6C? What element?
Is this the? Mm-hmm. Yeah.
Which one?
Alright, so
I thought I did.
Oh, you run off.
I can help you.
Should I call?
go help me.
This is 6C. I didn't do it.
Get rid of the times. Get rid of the times. Just 1.50 EE. What's that, 12? This is probably the one that has a really odd answer, okay?
What would it? It's 6. Oh. I was trying to memorize it. And
Wait, that's 6 or that's 7? I think I got it wrong.
What, 6.0? Oh, you said 6.06.
6.062.
Okay, never mind. I know what I
That's second rule. That's probably right. There's one that has a really weird number. What answers that?
Doesn't have grams on it. It's
Which one is that?
C.
6C is 2.65 times 10 to the negative 10.
Where is everyone? Real question. There is the.
2.6.
If I had made up the answer, it would be very strange. Okay, but sometimes the answer is it makes something strange. So if you know you've done the chart right,
I still ain't get a -10.
it's very possible. It's okay. All right. Other than Elijah thinking the answers just look funny, are there other questions? Other questions other than Elijah thinks the answers are bizarre?
I think you're just putting it in wrong.
I don't know.
What's he got?
You are putting it in wrong. Why aren't you doing second EE?
Good Lord.
Last time I did that, it was just,
I never used.
We don't say times 10 raised to the 23rd.
That's what I do.
All right. No, you don't.
I said, all right.
Okay, you need to stop that crap.
Oh, that's
All right, second EE. Now just tell the exponent is 12 times 35.45
I like a boy.
equals divided by 6.022
Boy to go.
second EE 23. There you go.
Look at you.
Okay. Other questions? Anybody else? Ring, you doing okay? Okay. Anybody else have an issue? All right, that's what your quiz is on tomorrow. Last night's homework is your quiz tomorrow. Everything's worth 20. 5 questions. 20 points each. Go ahead.
but even this right here, the application.
Yes, that application problem is fair game. Okay? All right, let's talk naming. Let me give you a chart.
You are taking notes?
Yes, we take them. It's a travesty, I know.
Are we done with the table?
Yes, matter of fact, we're done with the calculators. You want to put those up while you do the charts. That way they don't fall off your desks and hit the floors. All right. Hopefully I got everybody a chart. But you can put your calculators away. We're done with those for today. There you go. There's your title. Will that work for you? Okay.
What?
Nomenclature.
What? Okay.
You wanted a title? I gave you one. Now you're complaining about the title?
No, it's just like, are you being funny or like?
It's not being funny. That's what it's called.
Oh.
Nomenclature is a system of naming. Now, nomenclature is not unique to my class. Nomenclature can be used for any class. You can use it in biology. You can use it in applied sciences. You can use it in any discipline. It does not have to be strictly chemistry. Okay? Now, we're going to talk about two types of nomenclature. Slowly but surely, the calculators are making their way up here. Still missing two, but
This wall, you did not have to throw shade on me.
no, I'm throwing shade at the other two people, Janiyah, not you.
But I'm putting it away.
I'm getting there.
Okay.
Can I ask a question that's like completely irrelevant to this, but it'll only take 2 seconds to answer?
Yeah,
Do you have to take a math every year?
you have to have 4 maths to graduate.
Okay, so it doesn't have to be every
It
year.
does not have to be every year. You can double up.
Okay, sweet. You only need how many sciences?
You need 3. Science is the only one that does not require 4. Okay? So, there are 2 types of compounds we're going to learn to write the names of. And there's 2 systems we're going to use. We'll talk about the 2 types of compounds first. You might remember this, I hope, from another science class, because this part should be review for us. The 2 types of compounds we're going to learn the name of are ionic, which is what we're going to start with today. And the type we will probably get to, what's today? Tuesday, best guess, sometime Thursday, will be covalent. Okay? Now, we're not going to talk about the electrons and how the electrons move between the elements until 4 weeks or so from now. All right? We're going to talk about how to recognize them today. All right? So, to recognize an ionic compound, okay, this is not its definition. It's to recognize one. Okay? Using the periodic table, it will be a metal and a non-metal. Again, to recognize a covalent compound. And make sure I point out to recognize one, because it's not the definition that we will learn down the road. It's all non-metals. And I specify all non-metals because it can be just 2 or it can be more than 2. for us right now, it will primarily be 2. Now, those definitions or the ability to recognize ionic compounds are predicated on the fact that you can identify metals and nonmetals on the periodic table. So I'm counting on the fact that you remember where the metals and the nonmetals are on the periodic table. Now, for some of you, that's probably a falsehood on my part. So, let's refresh on where the metals and the nonmetals are for those of us who may have forgotten. Everybody have what they need? Do I need to wait? All right, so let's say for a moment that this is a periodic table. What determines where metals and nonmetals are at? The what? What basically determines where the metals and nonmetals are at? Come on, Zaya. I'm counting on you. There's a feature on the periodic table that's going to tell us where the metals and nonmetals are at. The stairs. Okay? The stairs.
I'm keeping up, I just
The stairs. Now, on the stairs, there's a grouping of elements that were referred to as something special. Right? Remember their name?
No.
Starts with an M.
Metalloid.
Metalloids live on the staircase. We're not going to concern ourselves with where the metalloids are right now. We'll talk about that when we talk about the periodic table. All right, but the staircase divides us into metals and nonmetals. So, where are the metals at in relation to the staircase? On the left. All right, so everything on this side is a metal. Okay, if you don't remember, metals are on the left. All right, nonmetals are where? Nonmetals are on the right. Now, there is one exception. Who is the one exception? Yeah, what's the one at the top? Hydrogen. Okay, hydrogen right here is the one exception.
What is it?
It's a non-metal. That's why I wrote it in red. Okay, hydrogen is a non-metal. It's the one exception. Okay, everything else on the left of the staircase, for our purposes, we will consider a metal. Everything else on the right is a non-metal. All right, so when we go to write names, we have to be able to tell whether something is ionic or covalent. So if we have something like Ca2, NaCl, Ki, can you tell me which ones are ionic and covalent? Now, you got a periodic table still handy? Write those 6 down. And just in your notes, write I or C, or you can write the words out. I don't care. But it's going to be important for the purposes of naming whether you can decide if they're ionic or covalent in 2 days. Okay? So figure out if those are ionic or covalent real quick.
Wait, didn't you say they could be both? What?
Say what now? It cannot be both. It has to be one or the other. You gotta choose.
What do you mean both?
It can't be both. It's gotta be one or the other.
No, like, how can, like, to recognize metal, non-metal, like, how can it be both?
If it has one metal and one non-metal, it can be a combination of,
Okay.
like it can have two metals and one non-metal, or one non-metal and two metals. If it has one of each, it's automatically on.
Okay, that makes more sense.
Okay.
I'm confused.
All right, here we got them. Still hunting for the elements. Where are we at? Okay.
Okay.
You having a bad day? Just wanted to exile yourself from the group?
What do you mean? Oh, you're not.
Yeah, Michaela back there. Okay, it's fine. I was just asking. All right, so CO2. What did you put? Covalent is correct. All right. So when you look this up, CO, or C rather, is a non-metal. O is a non-metal, so it's covalent. NaCl, what'd you put, Raylina? Yep. This is a metal. This is a non-metal, so it's ionic. Ki, what'd you put, Jocelyn? Yep. Metal, non-metal, ionic. Na2SO4, what'd you pick, Allie?
Ionic.
Yes, this is a metal, it's a non-metal, it's a non-metal. Any combination of a metal and a non-metal is always ionic. It doesn't matter if it's one metal and two non-metals, or if it's two metals and one non-metal. Any combination of a metal and a non-metal is ionic, okay? HCl, what'd you pick, Trevor? Covalent. All right, this sometimes throws people off because that's not covalent, stupid. Non-metal and non-metal, so it's covalent. They forget that hydrogen is a non-metal, and so they miss the covalent there. And PCl3, Janiyah. Yes, because it's a non-metal and a non-metal, so it's covalent. Everybody good with the process? All right, the reason we talked about this is because there are two systems of naming that we're going to learn. It would be fabulous if we only had to learn one, but we have to learn two, okay? We have to learn what's called the stock system, which is the one I refer to as the Roman numeral system. All right, it's the predominant system that we use today. It's often referred to as the new system. This one can be used with both ionic and covalent compounds. Okay? Stock system can be used with both ionic and covalent compounds. So it is the one we will lean most heavily on. Now, carbon dioxide because that's what you guys have always been taught. Okay? Using those prefixes like di. You can only use these prefixes if they are covalent. You cannot use any of those prefixes in an ionic compound. Okay? It doesn't work. And so that's why we have to learn the other system. And you have to be able to recognize an ionic compound or a covalent compound. Because some of you will stick those prefixes on the wrong compounds and you automatically get the wrong answer, which is why we have to know the difference. Okay? Everybody with me so far? Yes? No? Okay. So 2 different types of compounds, 2 different types of names. We are going to stick with the stock system for the better part of the week. We'll bring in prefix possibly Thursday. All right, is everybody caught up? All right, so we're going to talk about easy compounds today. First of all, the system we use is called the IUPAC system.
How many systems are there?
All the ones we use fall into this. You're going to see it in a test question on the exam. You're going to see it in the review. You're going to be like, well, what is that? And I'm going to tell you I taught it to you way back now. And you're going to be like, no, you didn't. Yeah, I did. It's called the International Union of Pure and Applied Chemistry. Okay, so everything we're doing falls under this heading. So when you see it in a test question, just ignore it and keep going. All right? So we're going to start easy. In math class, what does binary mean? I love y'all. Y'all must be all right in math class. Yes. We're going to start with binary ionic compounds. All right, so we're going to start easy. 2 elements. And because I said ionic, you know they're going to be what kind of elements? Metal and non-metal. Okay, and we're going to write formulas. Which I think is the easiest thing to do. Now, before we can write formulas, we have to use those blue sheets that I gave you. And the other day we talked about cations and anions, right? All right, so we need oxidation numbers. Most people do not teach it in the order I teach it. They do all the boring stuff first and kill the course so people have no idea what's going on. I teach it in a completely flipped order, and so y'all don't know how to find any oxidation numbers. So I'm giving you the oxidation numbers, which is on that blue card, okay? Now, if you look at the top of the blue card, it has a little thing written at the top that says the blue card will go away at week what? 12 or day 60. We're on day number 11 right now. So at day 60, the blue card goes away because I will have taught you all the skills you need so that you don't need that blue card anymore. Okay? So it's a crutch until day 60 when I've taught you all the skills you need. Got it? Okay. So in order to find the oxidation numbers, you can look them up on the card right now, but eventually they will go away. All right? So a cation is what kind of ion again? Y'all forgot already? A cation. An anion.
Did we learn that? I don't remember that. I don't think we did.
It's in your notes from last week. Yes, I'm sure about that. A cation is a positive ion. An anion is a negative ion.
Oh.
Oh. So, on your trusty charts, a cation is the positive ion, an anion is the negative ion. We even said the cation meant you did what with your electrons? That's right, because it lost electrons, just as a side note. And the negative ion was an anion, and it meant you did what with your electrons? That's right, you gained electrons. That's the context of where we used it. But yes, I used those words. Did I talk about that? For the love of Pete. All right, we caught up? All right, so we're going to write formulas. Formulas are easy, I think, which is why we start with them. And then we're going to write names. All right, so the steps for tomorrow are the same. So we're only going to write them down once. All right, so number one, look up the symbols. Now, I say that because if you write the wrong symbol, your answer's wrong. There's no partial credit. If you write the wrong symbol, your formula is automatically wrong. So if you don't know it, you need to look it up. Number two, look up the oxidation number. Now, positive element is first. The negative element.
First element is first.
Oh. Thank you. I said it right, wrote it wrong. Positive element is first. Negative element is last. Does that look and sound better?
Yes.
Okay. The positive element is first. The negative element is last. So when you write the formula and you look up the oxidation numbers, the positive element is first. The negative element is last. Now, depending on who you had in middle school, you might remember doing step 3. You're going to crisscross the oxidation numbers. Not the sign. The sign goes away. We're going to mark it out. We're just going to crisscross the oxidation numbers. In step 4, reduce if necessary. We will only need to reduce probably 10% of the time. Okay? We are not going to have to reduce very often, but we will have to reduce some, but not very often. Now, does anybody remember crisscrossing and writing some formulas in middle school? I know you do. We did it in physical science, so you should have a leg up on this. Anybody else remember doing it? Sometimes middle school will do this. No? Okay. Does anybody else take physical science besides design? No? Okay. All right, does everybody have what they need? All right, so if we write a couple formulas. All right, so let's start with something easy. Sodium oxide. All right.
This is like practice.
It's like me walking you through a couple steps, yeah.
Okay.
So, what's the symbol for sodium? Now, I will tell you how the chart is laid out, because it'll make life easier for you. Okay? In my infinite wisdom, because I tried to be smart, and it didn't turn out too well for me. If you look at this side, I alphabetize the elements. Okay? Name, symbol, oxidation numbers. Everybody got it? If you turn it over on this side, there's the rest of them alphabetized. A through Z. Okay? Then I thought, okay, the ones we're going to do tomorrow, the polyatomic ions, I just put these on this side. And once I put the others on there, couldn't shuffle and fix the alphabetization. So, most of the polyatomic ions are alphabetized, Then I realized I forgot some. So the ones I forgot are down at the bottom. Okay? But I couldn't fix it unless I wanted to retype it all, and I was just way too lazy for that. So if you can't find one of the polyatomic ions up here, look down at the bottom. Now, there are 4 acids you have to learn. You need to mark these on your sheet because you can't use this on the test. You have to use mine because I've taken the 4 acids off of the sheet. So they're the bottom 4. Here that say common acids. Highlight them, mark them, I don't care which. You have until your first quiz on naming. What's today? Tuesday. What's it? Thursday. Your first quiz on naming is Thursday. You need to know the 4 acids. There are the bottom 4. I just told you the bottom 4.
Iodine oxide.
Dude,
Yeah.
read the labels. It says acids, common acids. Bottom 4.
Hydrochloric. Okay.
So that will be hydrochloric, sulfuric, nitric, and phosphoric. Bottom 4.
What are they? For the.
Hydrochloric. Find the chart that says common acids. Now you people are not slow-witted, and I know you can read. The chart says common acids.
We gotta memorize.
You gotta memorize the names and the symbols for the bottom 4. Because I chose them. They're 4 of the most common you will ever see. Hydrochloric is stomach acid. When y'all puke and it burns, it's hydrochloric acid.
Yo.
Sulfuric is battery acid. Nitric is used in fertilizer. And phosphoric, those of you like me who like soft drinks, that's what's in it.
Diet Dr.
Why is it at the bottom of the note? Is it, do they match up with like mercury and all that stuff?
Say what now?
For the ones at the bottom, do they match up with mercury and all that stuff?
Yeah.
Okay.
All right. For today, we're pretty much staying on the left side though. Okay? Don't worry about the polyatomic ion side. We're staying on the left. All right. So what is sodium symbol? Na. All right. Oxygen symbol.
Oh.
Okay. Now, notice I wrote Na, N capital, A lowercase. You should not write this. You should not write this. Everybody got it? If you write those 2 things, it's wrong. It's capital, lowercase. All right. Oxidation numbers. So when you look up sodium, it only has 1 number there. Makes it nice and easy. It's a positive 1. Oxygen only has 1 number, I believe. Yep, -2. All right, so step 3, crisscross the numbers, not the sign. The signs are only there to help you make sure that the positive element is first and the negative element is last. We don't need the signs. Okay? +1 and -2. Plus and the minus we scratched out. We're crisscrossing only the 1 and the 2. So the 1 is on Na, right? It's going over to O. The 2 is on O. It's going over to Na. Anybody lost by what I did?
No.
Na has a 1. It goes over to O. 2 is on O. It goes over to Na. So when I rewrite it, it's Na subscript 2, O subscript 1. In math class, do I write X to the first or just X? X. We do the same thing in science class. We don't write X to the first. We just write X, right? So in science class, we don't write O to the 1. We just write O. Now, if you write Na2O1, I'm not going to mark it wrong, okay? But I will never write that, okay? I will only write this. Does that make sense?
Yeah.
Okay. Questions about that?
What do we need this for?
Huh?
What do we need this for?
What for?
The formulas.
What do we need the formulas for? Because y'all are going to learn to write equations and predict products and balance, and then you're going to add math in.
Yikes.
All right, calcium chloride. What's calcium symbol?
See that?
All right, what's chloride? Okay, chloride and chlorine are the same thing. We're going to talk about that IDE in just a second. All right, calcium has what oxidation number?
+2.
+2. All right, look up chlorine.
It's got a lot.
It's got a lot. So how are you going to know which one to pick? How you gonna know which one to pick?
Positive elements in first.
Positive elements are first. Negative elements are last. So which one are we gonna know to pick?
Negative.
The negative one. All right. You already picked calcium was +2, so chlorine has to be what?
What if? Oh wait.
Has to be negative. Okay. This is why I showed you that rule. This one is first, so it has to be positive. This one is last, so it has to be negative. So when you look it up, it says -1, +1, +3, +5, +7. It has to be -1 because it is last. Does that make sense?
Yeah.
Okay. So, step 3. I don't need the plus. I don't need the minus. 2 and 1 are doing what? 2 comes here. 1 comes here. Ca, Cl2. You with me?
Yes.
Okay.
Is that like 11 or 2?
It's Roman number 2. You can put just that like I did, or you can draw the lines like that if it makes you happy. Apparently, I need to do that if you thought it was 11. All right, so if we have copper 2 sulfide, we need to write the formula. We're getting ready to learn how to write their names in just a second. So you have copper 2 sulfide. Copper has what symbol?
C.
Cu.
Yeah.
If you don't know them, look them up. Don't get them wrong, because as soon as you write the wrong symbol on the quiz, it's -10. It doesn't matter if every other thing in the symbol or in the formula is right.
Your quiz tomorrow or Thursday?
I said Thursday.
Okay.
All right. Now, sulfide is what? S. That's sulfur. All right. So oxidation numbers. It's got how many numbers listed there?
2.
Okay. This right here is the oxidation number of the first element. Because it's a positive element, okay? And you looked up copper on the sheet. You said it had +1 and +2 there, right? We don't know which positive one to pick because it's got more than one listed there, right? So I have to tell you which one to use. I'm telling you to use which one?
2.
I'm telling you to use the +2. Okay? I'm saying +2. Right there. Now, sulfur. Look it up.
-2.
Okay. So you have -2 plus, does that +2 on there? +2, +4, and +6. All right. This one has to be a -2 because it's last. Now, when you crisscross, 2 comes down, 2 comes down. You have Cu2, S2. Now, this is like being in, math class. What happens to the 2 2s?
They cancel.
They cancel out, and you get CUS. Questions? Anybody? Feel okay about writing formulas? Zyra, are you with me? Okay. Anybody else? Janai's praying. See, that's what happens when y'all have 3-day weekends. Y'all get off your schedule.
Right. What I need to do.
I did too. Could have had a 4-day weekend and I'd have been good. All right, let's talk about writing names. All right, step 1. Write name of the first element.
Which one is this one?
It's still binary. Ionic. What's binary mean again?
2.
2, and it's a metal and a non-metal. Same kind of compound. We're not deviating. Starting easy. 2 elements, still metal and non-metal. Naming the first element. Step 2. Name second element. Add an IDE ending. That's why y'all saw things like chloride, sulfide, oxide. We got to add an ending. Number 3 is the hard part. Okay? Check the first element. If more than one oxidation number listed on the sheet include a Roman number. Okay. So we're going to write the first name. We're going to write the second name, but we got to add an IDE ending. And then the third one, third step, we have to check that first element to see if there's more than one number listed on the oxidation sheet. If there's more than one number listed, we will have to include a Roman number. If there's only one number listed, we will not use a Roman number.
So this is like they use the formula.
Yes, they gave us the formula and we're writing the name.
So which Roman number are we using?
Huh?
Are we gonna use the highest Roman number?
No, that's what I'm going to show you how to find. All right, am I still waiting on people to write? Are we caught up? Where are we at? I see Xavier's still right. You sure? All right, so let's say that we have, I don't know, let's go SRPR2. All right. So what is the name of SR? All right. So you write strontium. What's BR? I heard it. Bromine.
Bromine oxide. No.
Okay.
No, bro.
That's a great lead in. All right, turn your paper to side 2. And down at the very bottom, it says common spellings of binary ions. So for those of you who want to change bromide to bromine oxide over here, all right, the spellings are at the very bottom of the page. So you can spell bromine becomes bromide. Okay? So that's there so that by day 60, we can spell bromide correctly. Okay? Now, step 3. Look up strontium. How many numbers are listed? 1. Okay? Strontium only has, okay? It only has a +2. That is the only number on the sheet. Because that is the only number on the sheet, that means no Roman number. Because every time strontium is used in a formula, what will its oxidation number be?
2.
It'll be a 2 every time. You do not have to tell me in the formula, in the name, that it's a Roman number 2, because every time it's used, I will always know it's a what?
2.
It's a 2. You don't have to tell me that. Okay? Now, the flip side of that would be something like this. if we have Mn2O7. And I picked Mn because, again, it's often confused with what element? Magnesium. Okay?
Manganese.
It is manganese. So manganese. What is O? Oxygen, which we turn into what? Oxide. Now, you look up which element? Manganese. And when you look up manganese, how many numbers are listed for manganese?
A lot.
A lot. Okay, it has plus 2, plus 3, plus 4, plus 6, and plus 7, I think. Now, that's a whole bunch of numbers listed there, right? So we have to have a Roman number. You have to tell me the oxidation number used in the formula. Okay? So, let me not use that. Let me use this color. All right, so right here. This number right here came from right there. What number came from the manganese?
7,
The
sorry.
2 came from up there. So the 7 came from the manganese, right? So that's the number that goes in the Roman number.
Don't just write 7.
No. You cannot write a 7.
I don't know.
Okay. Right. Does everybody have what they need off this board? And I'll write all 7 Roman numbers. You only have to know 1 to 7. And I'll write the 7. So get what you need off the board and I'll write down 1 through 7.
She's getting louder, bro.
Oh, I don't mean to. It just happens. Sometimes I have to practice being quiet. Anybody have a question? Can I write down the 7 Roman numbers for Allie?
For all of us.
For all of you? Okay. So the 7 Roman numbers. 1, 2, 3, 4,
How high did it get?
5. You only go to 7.
Oh. Yeah, that's the biggest number?
Yes.
Oh, are you sure?
That's it. 7. I'm not lying. Why would y'all assume I would be?
I swear, it's easy because oh, there's not gonna be
No,
this
it's
on
on
the
the
test.
test.
Oh, I was lying. Like, no.
Here, I'll go to 10, but we will not go higher. There's 10. We're not going higher.
Thank you.
So we can never write number 2.
Say what?
We can never write number 2.
You can write a 2. You'll see a 2.
No, like in, never mind. Just how?
You wouldn't write a 2 in the one we just did, but you can have a Roman number 2, yeah.
Okay.
Because in the one we just did, the 2 2s would cancel.
Okay.
All right, does everybody have the Roman numbers?
Yeah.
All right, let's start homework. Now, your homework's on naming. But to clarify, is your quiz on naming?
No.
No, what's your quiz on?
Other
No.
thing with the
Mole conversions and possibly average
Oh, man.
mass. Okay? But your homework is on naming. Now, there are 2 sides to this. You are only doing the front side. Have I talked about how to do polyatomic ion yet?
No.
So do you know how to do the back?
No.
Stay off the back. You're doing the front. 1 through 19. The top has you writing formulas and crisscrossing. The back has you writing the names. You figure out where you need the Roman numbers. Can you just slap in Roman numbers because you're like, I'll just put them in to be on the safe side? Can you do that? No. If you need a Roman number and it's not there, it's wrong. If you don't need it and you put it in, it's also wrong. You have to figure out when you do need it and when you don't need it.
Wait, so we do have a quiz tomorrow.
Yes.
And we have one Thursday.
Yes.
Thursday is on quiz.
It's on naming.
Are you saying quiz tomorrow? Oh, wait.
I might not. I haven't decided.
She's gonna tell me.
All All right, I don't know if I have this in the folder, so let me scan this.